Deep pit mines, offshore oil rigs, and heavy manufacturing plants operate on a staggering scale. The machinery weighs tons, the physical forces are immense, and the margin for human error is zero. A specific paradox governs these sites. To safely operate an 80-ton excavator or a massive drilling rig, a worker requires deep, real-world experience behind the controls. For industrial operations, this creates a dangerous catch-22. The only way to acquire that essential experience is to put a complete novice at the helm of highly dangerous, complex machinery. Historically, this has forced a trial-by-fire learning curve. An operator learns how a crane handles during a sudden windstorm or what an engine stall feels like only by surviving those exact crises on the job. Organizations pay for this learning curve through unplanned downtime, destroyed equipment, and severe safety incidents.
This raises a difficult question for industrial leaders. How do you train a workforce to survive a worst-case scenario without actually exposing them to the worst case? The solution lies in displacing that physical risk into a digital environment. Using VirtuoniX industrial skilling solutions, operators face the danger in a simulation long before they touch a real machine. VirtuoniX utilizes high-fidelity full-motion simulators built specifically for heavy trucks, forklifts, excavators, and cranes. These rigs utilize 6 degrees of freedom motion platforms. This means the simulator cabin mechanically replicates the exact physical sensations of a real machine, matching the pitch, roll, and yaw, as well as the surge, heave, and sway of the equipment's actual movement. Matching that physical feedback with photorealistic visuals builds genuine muscle memory. The operator's brain treats the simulation as a real event, allowing them to gain experience without any real-world danger. This creates a zero-risk sandbox. Trainees are placed in a space where they can safely push boundaries, make mistakes, and learn from failure. Operating heavy machinery under perfect conditions is only the baseline. High-stakes safety training requires exposure to unpredictable, catastrophic variables. Trainers actively test operators using dynamic scenario injection. From an external dashboard, an instructor can instantly alter the simulated environment at the push of a button. Without warning, a trainee might face a collapsing crane load, an unexpected engine stall, or a sudden torrential downpour that eliminates visibility. As the trainee navigates the crisis, the system utilizes real-time performance analytics to track their split-second reactions. Every steering adjustment and braking decision is recorded, turning potential fatal mistakes into measurable data. This data-driven approach has major impact. High-stress simulations reduce overall workplace safety incidents by 48%. A global mining deployment shows further gains. This VR training cuts total training time by 75%, delivering a 2.7 times ROI. By surviving these engineered crises digitally, new operators compress years of veteran experience into just a few weeks of safe training. Once the operator steps out of the simulator and onto the job site, the VirtuoniX safety net follows them into the field. Through the expert guidance platform, tools like LiveLink Augmented Reality and the Ask AI connect field workers to remote technical experts who can see the equipment in real time. This remote support resolves 75% of technical issues on demand. It reduces the mean time to recovery, the time needed to get a system back online, by 37%. The final layer of protection involves stopping equipment failure before it starts through smart predictive maintenance. This wireframe shows how smart sensors feed data into a machine learning health score engine. The system analyzes vibration and wear patterns to forecast mechanical failures before they occur. This forecasting allows for auto-scheduled maintenance, which reduces unplanned equipment downtime by 30%. By linking simulation training with live sensor data and remote support, industrial operations transition from reactive crisis management to proactive prevention. The best way to survive a catastrophic workplace failure is to solve it before it begins.